Welcome to our series on how to get a full score on the AP Computer Science Principles test. This is part 3, so let's get started. So we're going to start off this part by talking about different parts of the AP exam. That is the Explore task, the Create task, and the Multiple Choice exam. I'm also going to talk about the different steps you need to do to submit the Explore task and the Create task onto the digital portfolio and some requirements for submitting. After that, I'm going to talk about how to prepare for the written exam, and I'm going to supply some materials you can use to prepare. Once we're done with that, I'm going to go through the rubric and scoring guidelines for the Explore and Create tasks and tell you what each part means and how you can fulfill that part. Finally, I'm going to summarize by covering up what to care about to get a score of 5 instead of a 4 or a 3. So let's get started with this. Now let's talk about the parts of the exam. So most of you know what the end of course exam is, but did you know that's only 60% of your total AP score? The other 40% is made up by 2 performance tasks, the Create task and the Explore task. And both these tasks you can do at home, and they're all due on April 31st, so before the actual exam takes place. And so these are fairly important, but they're also easy. And that's because you have a lot of time to research at home, and you have a lot of time to actually make your task. In addition, the criteria is fairly simple. Graders will just check if you have what's on the rubric, so you don't have to make anything flashy or important. It just needs to follow the rubric and you'll get a 40%. And so getting a 40% because of this is fairly easy, and if you get a 40% on the Explore or Create task, then even if you get 80% of the questions right on the end of course exam, you'll still be able to get a 5. And so because of that, I'd recommend that you spend some time focusing on both these tasks. Now, I've been talking about these 3 parts a lot, so I'm now going to tell you what they are. Let's start with the Explore task. Now, the Explore task requires you to create a computational artifact about a certain computing innovation. And so, computational artifact, the term sounds complicated, but all it really is something visual that explains what your computing innovation is and how it works. And so your computing innovation doesn't have to be anything complicated per se. It just needs to be something that uses computing fundamentals to do it. For example, many people use self-driving cars. I use cashierless stores. And so the actual task involves you to create a computational artifact which shows you how it works and what your innovation does, and some written responses which explain how you made your artifact and require you to go more in depth into how your computational innovation works. And so I'm going to show you what I did for this in the next part and how I managed to follow the rubric to get all the points necessary for this. Now let's move on to the Create task. So the Create task has you creating a program of your own. And this program can be anything you like, but you should have a video of your program running, some responses indicating how you made your program, what it does, and how it works, and you should paste the code for the program in. And this program, it doesn't have a theme, and it doesn't have to relate to your Explore task. For example, if my Explore task was about self-driving cars, my program doesn't have to be about self-driving cars. There are only 2 constraints for the program, and that's that it should have at least 2 algorithms, and that one of these algorithms should use mathematical principles. And so both of those sound like daunting terms, but it really isn't that bad. By algorithms, they just mean step-by-step instructions for how your program works. So say, you could make an algorithm talking about saying, if my name is Ohm, print the letter Ohm. And For mathematical principles, it doesn't have to use calculus, it doesn't have to use even algebra. Checking if one number is greater than the other, or adding 1 to a number, those are both examples of mathematical principles being used. And you can use any programming language you'd like. You could even use something as simple as Scratch. Again, it doesn't have to be a really fancy program, it just needs to fulfill all the requirements in the rubric. Later in the series, I'm going to show you my Create Task program and how I managed to make it exactly follow the rubric. Finally, there's the written exam. Now, the written exam is only multiple choice because the written responses have already been done in the 2 tasks. And so this is the actual paper they put in front of you at school on the day of the exam. And so this will usually be mid-May. And since it's all multiple choice, you should be able to do good if you're just clear with all your topics. And so we'll provide you more details of what material you can use to study and how you can prepare for this exam later in the series. Now that we've talked about the parts of this exam, let's go on to the digital portfolio to talk about the steps we need to take to submit the tasks. Here we are at the page for the AP Digital Portfolio. You can get here by going to AP Central, then the AP CSP page, then the exam, and then find the link for About the AP Digital Portfolio. And so, I mentioned what the digital portfolio was last part, but in case you missed it, the digital portfolio is where you submit the performance tasks for the AP CSP exam, so where you submit both the Explore and the Create tasks. So clicking this link brings us to the actual digital portfolio. And so if you've already signed up for the AP CSP exam, you should see the AP CSP page right here. In my case, I've already finished it, so I'll go to Archived Classes and then to AP Computer Science Principles. Now we want to go to Explore task, and we see 2 parts, computational artifact and written responses. So written responses, you can tell. In case you don't remember what the computational artifact is, it's basically it's something you make visually that explains how a certain computational innovation works, and it focuses on how the different parts of it interact and how computing fundamentals help it work. So you can make a flowchart or a slide or something like that. So clicking on it, we can see the submission guidelines right here. So we can submit it as a video or audio file, or we can submit it as PDF file. So PDF file is for images, and a video or audio file is if you want to explain by talking. So a video file isn't necessarily better than a PDF file, and vice versa. I personally chose a PDF file, but it's really mostly up to preference. And I'll show you my computational artifact next part when I show you my Explore task. So a few more submission guidelines. PDFs can't be greater than 3 pages, and video or audio files can't be longer than 1 minute, and they can't be greater than 30 megabytes. So this button is where you download the file, where you upload the file. In my case, it says download. In your case, it should say upload. It just says this for me, because I've already submitted the final. Now, let's move on to the written responses. Submission guideline. So in the submission guidelines, it says submit 1 PDF document. First, though, you want to download this Word template. It's in Word, and once you download it, it has 5 boxes in it, and each box is for a different response. So there are 5 responses in total, and you want to either copy and paste your answer or type your answer in those boxes, then convert it into a PDF so that you can submit it. And so each response, 2A to 2E, has an entry on the rubric. And when I show you my Explore task next part, I'm going to show you the rubric, I'm going to show you the Word template, and I'm going to show you my responses. And the response to every prompt in total cannot be greater than 700 words. Now let's move on to Create task. The Create task consists of 2 parts. the video, the written response, and the program code. Now the video is where you show the program running, and you can also explain how the program functions. This is not, however, where you explain the actual code and where you show it. And this will be more clear later in the series when I show you my create task. After that are the written responses. The written responses are where you actually explain what the code does. You can explain that. You could explain how the code works, and you could explain how the code was made. Finally, the program code is where you copy and paste your entire program. It's important that you remember to put in your whole program, because if the graders can't match your program to what's actually happening in the video, they won't give you full points for the program. So first off, this is where you submit the video. So the video must not exceed 1 minute in length and can't be greater than 30 megabytes. Now, 1 minute might not seem like a lot of time to explain what your program does, so it's optional to explain this in the video. You can explain what the program does in the written response and explain nothing in the video. You can also explain nothing in the first request of the written response and explain it only in the video. I did both because I was able to explain what my program does without exceeding 1 minute, and I was able to write it in, so I decided to write it in just to be safe. And this is the button where you upload your video as one of these files. Next is the written response. So to actually submit it, it's very similar to the Explore task submission using your template. So just download the template, copy and paste your responses into the template, and some portions of your program code, which they'll ask for. And once you've done that, convert it into a PDF so that you can download it. While the Explore task written responses shouldn't exceed 700 words, the Create task written responses should not exceed 750 words. Next, there's the program code. Now again, this is where you paste your entire program code, and the oval is where you should mark your two algorithms and your mathematical concepts. So the part earlier, you should mark with a rectangle where you have abstractions. So I'm not going to explain abstractions in this video. You can learn it on your own, as that's more subject matter. So I'm going to show you my abstraction, the oval, and the rectangle when I show you my create task later in the series. And this is where you upload your program code. Now that I've talked about the steps we need to submit the tasks and the submission requirements, let's move on to talk about how to prepare for the exam. I'm not going to be teaching anything, I'm just going to provide you material. All the material is going to be in the description. So there's a lot of possible study material that you can use to study for the AP CSP multiple choice exam. And a lot of this material we've put in the description. So we've compiled a bunch of links, which I'm going to show you in this segment, and we've put them all in the description. So some of these links I've used myself, they've helped me with the AP exam. Some of these links I found specifically for these videos, but all of them are pretty good links and resources, so they should help you a lot studying for the AP CSP exam. Now, if you're in an AP class, your first and best resource is your school and your teacher. You can ask them for help. You probably have a textbook in school, and you're taking the class and doing your work. So if you do that, that's already a really good way to study for the exam. And if you complete the whole course, then you'll be able to do very well on the test. The next material would be the College Board website. So the College Board website has some resources that you can use to study for the test. So just go to the exam for APCSP and then classroom resources. And now if you go to learning list resources here, then you can see a lot of different resources for computer science principles. And you can see a few more listed here for APCSP. And so these official resources should help you with studying for it. There's also a really good code.org course. I used this myself to study for the APCSP test. And so the course, it's fairly thorough and talks about many different things related to APCSP. And they keep APCSP learning very up to date, the newest versions. So, and there are many different tasks, so it's a really good resource. You can also find some books in your local public library. For example, this is the books you can find in a library near me. And there are plenty of other textbooks you can find for APCSP. So, for example, I used books by Barron's, Princeton Review, Kaplan, and such. So looking for books is another very good way to find good resources. There are also several online resources. Some are free and some are paid. For example, one nice resource is albert.io. This is one example of an AP Computer Science Principles course. There's a lot of different ones, but you can have many different courses, and if you pay a little, you can actually have more practice. But these courses that you can get for free are fairly thorough, and if you want to pay for it, you get a lot more units. So you could also use Quizlet. There are plenty of different nice Quizlet things online which you can use for the APCSP test. And so if you're not familiar with Quizlet, it lets you have flashcards, it lets you take tests, and lets you learn a lot of vocabulary, and you can have fun while learning with some games. So if you search APCSP on Quizlet, you can find a lot of good results that'll help you with it. You can also find official school resources. So a lot of nice teachers have posted resources on their school website, which you can find. For example, this APCSP teacher has posted a lot of these resources, so you can go through them and work on them for some more practice. In the same way, this teacher also put on some APCSP resources, and she's organized a lot of different resources. And if you Google for it, you can find a lot of other good school resources for APCSP. There are also plenty of good books that are available. I mentioned this with our local public library, but for example, here's one of the books that I used. I used the Kindle to read it, and if you have Kindle Unlimited, it's free, and it's a really good book. It's a really good book that helps a lot with computer science principles, and this is one that I read through and used. Now, finally, there's what you're watching right now. You can find plenty of nice YouTube videos that'll show you what to do. For example, if you search APCSP on YouTube, you can find a lot of these videos which will help you with certain tasks and help you study for the APCSP exam. For example, if you search this on YouTube, you'll find all of my videos, so that's nice. So with these study aids, with enough practicing all of this study material, you should be able to get a good enough score in multiple choice exam to get a 5. I've explained how you prepare for the written exam, so now let's go back to the explore and create tasks so I can go over the rubric and scoring guidelines for both tasks. Now we've come to what is perhaps the most important thing to getting a 5 on the AP-CSP exam. This is because the explore and create tasks together make up 40% of the total AP score. This means that even if you don't do perfectly on the multiple choice exam, if you get a full score on both the explore and create tests, then it's very likely that you'll get 5 on the full AP exam. You can only get a full score on the explore and create tasks, however, if you remember to follow the rubric exactly and to the letter, and that you remember that there's no subjectivity involved. It doesn't matter how cool looking or fancy or complicated your program is. All that matters is that you followed the rubric to the letter. You make sure that everything in the rubric is followed in your explore task or create task. If you do that, you're basically guaranteed to get a full score on the explore and create tasks, and that makes it very likely that you'll get a 5. So let's start by looking at the explore task scoring guidelines and notes. Now this is the rubric for the explore task. So one thing to note is that the College Board is very thorough with this rubric. And so one thing to notice is that this row doesn't mean like an actual row in the response, it means each point. So each row is a point, and you can either get the point or you cannot get the point. So this column shows the scoring criteria, and basically just it tells you exactly what you should do and how it works. So in this case, you would do this and this to get the point. This column is the scoring notes, and the scoring notes just clarifies things in the other columns and defines some things. These are the decision rules. So this paragraph tells the grader how it should grade and some things that they can do. And this part tells what not to do to get a point. So if you do any of these things, then you will not get a point. So it's very important that you look through all of these. And remember the bullet points so that you can internalize what you should do and what you should not do, so that it's very clear what you need to do to get that point and get a full score on the Explorer task. So to start going through the rows, row 1 deals with computational artifacts. So the scoring criteria, the computational artifact has to identify the computing invasion, and then it should explain the computation invasion's intending purpose, function, or effect. So the purpose is what it's supposed to do, the function is what it does, and the effect is what impact it has. So if you explain one of those, then it should work. Then you should get a point for it. Next is row 2, which is for response 2A. And this is just to state a fact about the purpose or a function. So, for example, if I said that a self-driving car's purpose is to get people from one place to another without needing a driver, I'd get a point for response 2A. After that, for row 3, is response 2C. Now, you'll note that it goes straight from 2A to 2C. There's no mention of 2B. And so 2B is just asking how you made the artifact, and it's very likely that that question is just for the graders to know, and it doesn't have any relevance to actual points. So you don't get any points for that question. And so there are 3 rows that for response 2C. So the first one is row 3, which has you identify at least one effect. So one effect of self-driving cars would be that since self-driving cars are more accurate than humans, there would be less accidents on the road. This would be one effect, so I get a point for that. Row 4 is similar to row 3. It has you identify a beneficial effect and identify a harmful effect. So the effect I stated earlier for self-driving cars would be a beneficial effect. I could perhaps say that putting taxi drivers out of business would be a harmful effect. Saying both those things would get me a point for row 4. Row 5 indicates how one of the effects relates to the world at large, so how it could relate to society or culture or such. So going further with the self-driving car example, if I said that a self-driving car affects society because less and less people will learn how to drive and more people will rely on the self-driving car, then I'd get a point for row 5. Next one is row 6 for response 2D. And this involves you identifying what data it uses and how that data is taken in or changed. So, going further with the self-driving car metaphor, the self-driving car could use GPS data, that's the data that's identified, and it could use road pattern data, and it could take in this data with sensors in front or a GPS. So by saying those things, I get a point for row 6. Row 7 gives you a storage, privacy, or security concern. So to get the point, you have to identify one of those 3 things to the computing invasion. So with self-driving cars, I earn the point by saying that self-driving cars log where you are at any time, where you've been, where you're going, where you stopped off, and so it would be dangerous if a hacker got into that. So that would be one concern, and that would get me a point. The final row has you give references through in-text citations, and you need to use at least 3 different sources. One other thing which I've read, but which isn't stated in the rubric, is that all the sources need to be less than a year old. So they can't be older than a year. So now that we've gone through the Explore task rubric, let's move on to the Create task rubric. Here is the Create task rubric. And it's in basically the same format as the Explore task scoring guidelines. So let's go into each individual task. So the first part is video response, or 2A, and that's a row 1. And the criteria is that video should demonstrate the running of at least one feature, and that the response should tell the purpose of the program. So, for example, let's say I'm making a program where if you press one button and enter a range, it'll tell you all the even numbers in that range, and if you press another button and enter a range, it'll tell you all the odd numbers in that range. So that's a very simple program, and the program I created is more complicated than that, but the point is it doesn't have to be that complicated. It's complicated for a different reason, and it doesn't have to be complicated to get points. So as to demonstrate, that program would get this point if I showed the program printing out a list of all even numbers in a range that's running at least one feature, and I tell what that program does, aka print even or odd numbers in a range. And that would get me a point in row 1. Row 2 tells you to design and outline steps in an iterative development process. So what an iterative development process is basically just run it, look for errors, fix it, make it better, fix logic, run it again, fix it, make logic better, run it again, and just iterate through the program until you have a program that you're satisfied with. So for example, if I ran my program the first time, I might end up realizing that instead of even numbers, the program's printing odd numbers, and instead of odd numbers, the program's printing even numbers. So I'd go back through the program, I'd fix that issue, and I'd retry. That would be an example of iterative development, and that would get me a point. And again, so this isn't anything complicated, and that's with a lot of these things. They might use complicated words, but the concepts themselves aren't all that complicated. Row 3 involves giving 2 program development difficulties and describing how they're resolved. And so row 3 is for response 2b, just like row 2. And so the one I mentioned earlier would be a program development difficulty, which I eventually resolved. Another development difficulty might be that the buttons didn't actually do anything. It wouldn't connect to the actual program that printed even or odd numbers, so I could fix that, and that'd be another example of a difficulty that I resolved. So I'd get a point for saying that. In row 4, you get a point if the code segment implements an algorithm. And an algorithm, as explained earlier, is just a step-by-step set of instructions that tells the computer what to do. So, for example, an algorithm could be, if this button is pressed, print all the even numbers in this range. That would be an algorithm, and so I'd get a point for row 4. And this is for response 2C. And response 2C and 2B both have a code segment. It's a picture that you paste in, and then you write a response below it. So row 4 is what you want in the code segment for 2C. Row 5 is also for response 2C. And basically, this checks if your algorithm uses mathematical logical concepts, explains how the algorithm functions, and describes what it does in relation to the overall purpose of the program. So, for example, an algorithm that would use mathematical concepts is the algorithm that would print all the even numbers in a certain range. So, by saying that, I'm describing what it does in relation to the overall purpose of the program. It's one of 2 things. If you press a button, this is the algorithm that prints out all the even numbers, and I'm explaining how it functions by printing out all the even numbers, and it loops through numbers to do that. So that would get me a point. And it's a really simple program, but would still give me points for implementing all of these ideas. Again, the program doesn't necessarily have to be complicated. Row 6 is for a code segment implementing an algorithm that includes at least 2 or more algorithms for response 2C. And at least one of the algorithms should use mathematical concepts. So, in my case, this would be the algorithm for pressing a button. If this button is pressed, that's one algorithm, and then it would print all the even numbers in a certain range. That's another algorithm. And I can explain how one of the algorithms, the even one, functions independently. That would give me a point. Now, row 7 is about applying abstraction, and it's for the code segment in 2D. And so abstraction sounds like a kind of big word, but at the most, a really basic example of abstraction is using a function. In our case, it could be a function to call even numbers, and calling that in the program. It's an abstraction because an abstraction is something that keeps you from the complexity of the program. So procedures, like functions, are examples of abstractions. So what our thing does, even though it seems really simple and abstraction seems like a big word, our thing does have an abstraction in it. Row 8 is applying abstraction, and it's the actual response, and that's just what I did. Create an abstraction that matches the complexity of the program, so I get a point for that. So what this whole rubric demonstrates is even a really simple program still fills all the criteria. I don't really have to make it extremely complicated. I think I've finished everything I need to talk about for this part. So let's end the episode by summarizing what the most important parts in this part are to getting a score of 5 on the AP-CSP exam. So one thing I noted was that 40% of the total AP score is from the Create and Explore task, while 60% of the total AP score is from the multiple choice exam. Now, I showed you the rubric for the Create and the Explore tasks, and I talked about how it was important to get a full score on both exams, so that you didn't have to score, you could still score not perfectly on the multiple choice exam and have a good chance of getting a 5. And so I showed you the rubric and what rules to exactly follow to make sure that you get all the points available for the Create and Explore tasks. I also showed you what each part meant, and I gave you some examples of things that could meet the criteria for those rubrics. So with this, you'll be practically guaranteed with work to be able to get the full score 40% on the Create and the Explore tasks. In addition, I showed you the material you could use to study for the multiple choice exam, and with practicing that material enough, you'll be able to get a high enough score on the multiple choice exam to be able to get a 5 on the AP-CSP test. If you're in a class, then I'd recommend you just you get help from your teacher, you listen in class, you do all your work, and you'll know everything to get a 5, though doing some of the material that I've provided today will also help you. So in the next part, part 4, I'll show you what I submitted for the Explore task, the written response, and a computational artifact, explain why I chose the topic I did, and how I managed to match all my parts to that of the rubric. And thank you for watching, and remember to subscribe to our channel so that you can get notified every time there's a new part of this series, and so you can find new informative videos. Goodbye.